Okay, this is Module 16, Find and Use Slopes of Lines. A lot of this module is just a basic recap of some of the important parts of algebra that you're going to need for this particular chapter. So we have to recall what slope is. And slope is, it's the slope of a non-vertical line is the ratio of vertical change, rise, to the horizontal change, run, between any 2 points on the line. And it has to be a non-vertical line, and the reason is because a non-vertical line, or a vertical line, will have an undefined slope. And we'll talk more about that. But if a line in the coordinate plane passes through the points, let's call them x naught 1, y naught 1, and x naught 2, y naught 2, then the slope m is going to be the change in y over change in x. This is the main formula that you need and you should recognize from algebra. And we use m for slope. So you say m equals y2 minus y1 over x2 minus x1. So rise over run is the rate of change, basically signifies slope. So a negative slope falls from left to right. And just think of you're skiing down a hill, you're going to be falling, that's going to be a negative slope. Positive slope is when you're, think of a plane taking off, you're going up from left to right. Zero slope, horizontal line, I always think of the horizon when you have like a sun, horizon, sun rises. That's my weird way of thinking it. And then you have, of course, a vertical line, that's the undefined slope because you will have a bottom in that equals 0. So, and I'm putting lines here just to kind of give a little bit of a model as to how these are. But again, you should remember these or recognize these from algebra. So it says find the slopes of line A and line D. Okay, so line A, we look at line A and we see that line A and line D both pass through this point 6, 4. Line A also has the point 8, 2. So I'm going to find the slope by doing change in y over change in x. So I do 4 minus 2 because here's my x value and my y value and my other x value and y value. If you want to put sub 2 just to signify the 2. And I do y minus y value. And so 4 minus 2, x minus x value, 6 minus 8, evaluate it. Keep it in fraction form if it doesn't simplify to a fraction, or if it simplifies to a whole number, you can also keep it as a whole number as well. So this particular one is negative 1. So we have the slope of line D. Again, they both go through the point 6, 4. And then here's my other x2, y2. And when I show the rise over run, the rate of change, y2 minus y1, and I do that, I get 0 on the bottom. 6 minus 6 gives me 0. And if you plug this into a calculator, this particular one, it will give you an error message. Now you have to be careful what calculator you do, because just recently I saw that iPads actually have an app of a calculator that says that this evaluates to 0. This is undefined. So we say it's undefined because it gives an error. So postulates, again, in geometry, we're going to put postulates and theorems to things because those are our definitions. So slopes of parallel lines, if you remember in algebra, the slopes of parallel lines are going to be the same. They have the exact same line. And any 2 vertical lines are going to be parallel. So same slope and perpendicular lines in a coordinate plane. 2 non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. I always kind of remember it as negative reciprocals of each other. So I will give an example, but horizontal lines are going to be perpendicular to vertical lines. But if I have a slope, and let's say I figure out my slope is 1, 2 of my first line, think of the negative reciprocal. Well, the one that's going to be perpendicular is going to have the negative reciprocal. So you do the flip of this, so it'd be 2 over 1, and then you take the negative of it, or the opposite of it. So these two lines, slopes of these lines, are going to be perpendicular. They're going to form a right angle. So, which lines are going to be parallel in this figure? You can't just say, oh, these kind of look like it. You have to show it. You have to prove it. So, looking at these in your notes, again, y2 minus y1 over x2 minus x1. So you do that with each one, with k1, k2, and k3, and compare the slopes. So if you do that, you find that k1, change in y over change in x, evaluates to 4. k2, change in y over change in x, evaluates to 4 as well. But k3 evaluates to 5. So this guy here is kind of the anomaly. These two have the exact same measurement or slope calculation. So if these two guys have the same slope, that means automatically they are going to be parallel. K3, since he's got a different number evaluated, that means he's not going to be parallel. He's not special. Oh well. Okay. Drawing perpendicular lines. So we have line H passes through the point 3, 0 and 7, 6. Those are our 2 points. Graph the perpendicular line, or the line that's perpendicular to H, that passes through the point 2, 5. Okay, so passes through the point 2, 5. What you basically do is you figure out the slope of the first line of line H, and when you do that, you do change in y over change in x, gives you 6 over 4, and you evaluate to 3 over 2. So this is your first slope that you're dealing with. Since we're graphing the line that's perpendicular to it, we know, and I can do without the calculations, here, we know that M1 slope is 3 over 2. So you take the negative reciprocal of it, the flip, and then the opposite sign to get negative 2 over 3. So if that's the case, once you find that, you use this from 0.25 to go rise over run, down 2 to the right 3. Down is positive or is negative, to the right is positive because you have a negative on the top and a positive on the bottom. Once you do that, again, you only need 2 points to create a line. You can draw the line that goes through those 2 points. It'll also indicate with a right angle that signifies that these 2 lines are perpendicular. Okay, so here's another example. So we have a skydiver made jumps with 3 parachutes. The graph shows the height of the skydiver from the time the parachute opened to the time of the landing for each jump. Which statement is true? So we have the parachute open at the same time, or at the same height in jumps A and B. The parachute was open for the same amount of time in jumps B and C. The skydiver descended at the same rate in jumps A and B. And then we have the skydiver descended at the same rate in jumps A and C. So, the rate at which the skydiver descended is represented by the slope of the segments. So, you have your height here, and you have your time. So, as time goes on, if they're in a plane, they're going to start at a high altitude and be dropping. Their slopes are going to be negative. So, the segments that have the same slope are going to be A and C. Now, visually, you can look at that. You'd have to actually prove that using the slope theorem, but we can kind of visualize and say, okay, yeah, these look like they're parallel. So I would say that the skydiver descended at the same rate in jumps A and C because the slopes are comparable. Now, the parachute opened at the same time, at the same heights in jumps A and B. Well, we don't really know that. We can't really decipher that. The parachute for B, the parachute was open for the same amount of time in jumps B and C. Well, that's not true, because you can see in B, here was where it actually was time-wise was spent, and here was the time-wise that was spent, so they're completely different. So B is out. And then for C, the skydiver descended at the same rate in jumps A and B. Well, you can look and see in A and B, they are completely different slopes. So, for example, this is A and B. So these two slopes are not the same. So if they're not the same, then that means they're not descending at the same rate. And that's it. So the correct answer is going to be D in this case.